So the focus for today is on the application of Newton's second law of motion. So let's see this situation. It says grade P of mass 1.25 kg is connected to another grade Q of mass 2 kg by a light inextensible string. The two grades are placed on a rough horizontal surface, meaning frictional force is there. A constant force of magnitude 7.5 newtons acting at an angle theta to the horizontal is applied on grade Q, as shown in the diagram. The grades accelerate at 0.1 meters per second squared to the right. Fine. Now they say grade P experiences a constant frictional force of 1.8 newtons and the grade Q a constant frictional force of 2.2 newtons. Awesome. Now the first question says, state Newton's second law of motion. Well, I trust you can do that. The next one says, draw a labeled free body diagram for grade P. So by now you know you have to draw the free body diagram as well for grade Q, but on your rough work section. It's absolutely crucial. Fine. So let's go to the whiteboard for that. So this is our block P. This is how it looks like. Now, because it's on the horizontal surface, the surface will exert an upward force, which is perpendicular to the surface. So we call it the normal force. And then because there is no other force acting at an angle on block P, then it means the normal force will be equal in magnitude to the gravitational force or the weight. Fine. So because block Q pulls the block P to the right, then it means we are going to have tension force. And because the surface is rough, we have kinetic frictional force that opposes the motion of block P. So this is how you'll say it. Fine. Then we go to the block Q. And remember, the mark allocation for the free body diagram will never deceive you. You see 4 marks, it means 4 forces must be there. Right. Now we go to block Q. So the block Q is also resting on a horizontal surface. Well, it's not resting, sorry, it's moving. So we know that we have normal force, like that. And then in this case, the gravitational force will be bigger or larger than the normal force. Why? Because there is a vertical component of the applied force, which if we add to the normal force, the sum will be equal to the gravitational force. Then you'll say, this is what you have. And then you'll say, this is your F applied. Yes. And then you'll say, there's going to be a tension force that is applied by the block P. So it's going to the left. And there's also kinetic frictional force, which is going to the left as well. So this is what we have. This is the free body diagrams for 2 blocks. Awesome. Now let's see the next question. Well, they say calculate the magnitude of the tension in the string. So the question is, how do we do that? Well, the first thing we realize here, we can't use the block Q to find the tension. Why is that? It's because we have an unknown angle theta. So because the angle is unknown, it means we can't resolve the applied force into its horizontal component. Do you see that? We can't. So it means we have to use block P alone. But it's a challenge because this is a system of two blocks, right? Well, it's about to become a solution. Why? Because we are given the acceleration of the system. Do you see that? So we know that the block P accelerates at 0.1 meters per second squared. So if we have the acceleration, we can use the block P alone. Are you fine? Awesome. So let's go ahead and calculate the tension. So we tell them that we are considering the block or the grade, it's up to you, P, right? So if we look at grade P, we tell them that the net force acting on this grade is equal to MA. But what is the net force in this case? And we didn't assign the direction. Do you remember that? But if you remember in the previous video, I told you that we take the direction of motion as positive. So in this case, right is taken as positive. This means the tension force will be positive and the frictional force will be negative as a result. So you'll say, if you take the tension force, you add it to the negative of the frictional force, this must be equal to MA, like that. Then you say T minus, they told you that the frictional force acting on the block P is 1.8 newtons. Well, the mass of this block is 1.25 kg. The acceleration is 0.1. So this is physical sciences. You don't need to show us your workings because we only mark the formula substitution and the answer. We don't mark your simplifying. But of course, you can simplify so that you don't make mistakes. Well, I'm just going to punch everything into my calculator. So here I'm going to transpose the 1.8 to the right. So when it gets to the right, it becomes positive. So the result here will just be 1.93 newtons. So this will be our tension force. Right. So they are happy now because we found the magnitude of the tension. So what about the next question, which is actually the last one? They say calculate the magnitude of the angle theta. Do you see that? So when we must find theta, we can't talk about the block P. We have to consider the block Q alone because the force is acting on block Q. Are you fine? But how are we going to find theta? We are not going to use trigonometry in this case. We have to use Newton's second law as well. This is not mathematics. Fine. So this is how we say it. Yeah, we can get rid of this free body diagram. It has served its purpose. So let's go. We tell them that now we are considering the grade Q, like that. Now, we also tell them that the net force acting on grade Q equals MA. But what is the net force in this case? I want you to see that we have a component of the applied force that is in the X direction or the horizontal one. So it's going to be positive in this case. So you say F in the X plus what? The negative of the tension force plus the negative of the kinetic frictional force. Everything equals MA. Now, what is F in the X? We know that it's F cosine theta. But what is F? F is 7.5, and then you say cosine theta. Then you say minus the magnitude of the tension we already calculated, the kinetic frictional force acting on Q, it's given to us in the statement as 2.2 newtons. The mass of this block is 2 kg. The acceleration is 0.1, like that. Now, on the left-hand side, we are left with 7.5 cosine theta. Then we take everything to the right. So we say 2 times 0.1 plus 2.2 plus 1.93. Then we get 4.33. From this point, we divide both sides by 7.5. Then we find that cosine theta equals 0.5773, and this one is recurring, like that. Then we use our trigonometry and find the arc cos of this whole thing. So then it means our angle theta will just be 54.74 degrees. And then you should be happy again. Do you see that? Yeah, it's just a matter of being decisive. You have to see which situation is relevant to which block, especially if you are given the acceleration or the tension sometimes. Yes, I think this should be it for this question, right? Yes. So thank you so much for watching. I really hope this video helps a lot.